morning to everybody. Okay, today I will be discussing about the heterocyclic compounds. Okay, which is very important topic of third BSc students in organic chemistry. First, we have to know what is organic chemistry. Okay, organic chemistry is the branch of chemistry which deals with the organic compounds. Again, what are organic compounds? Organic compounds are those compounds whose backbone chain is made up of with carbon atoms. Today, my presentation is about heterocyclic compounds. Okay, in this we will discuss about introduction of heterocyclic compounds and definition of heterocyclic compounds. Classification of heterocyclic compounds and aromatic character of heterocyclic compounds. Okay, in this we will discuss the first one, that is introduction of heterocyclic compounds. Okay. Heterocyclic compounds are cyclic compounds in which it contains one heteroatom or atoms at one or more corners of the ring. Okay, these heteroatoms may be oxygen, nitrogen, sulfur. Okay, these heterocyclic compounds may or may not aromatic in nature. For example, alkene oxides and cyclic anhydrates. Okay, in sense, these two are heterocyclic compounds, but generally these are not considered as heterocyclic compounds because these are very unstable compounds. Very unstable compounds. Okay, for example of these alkene oxides, let us see the structure of ethylene oxide. Okay, this is a ethylene oxide. And example for this cyclic anhydride is succinic anhydride. CH2, CH2, C double bond O, C double bond O, O. This is a succinic anhydride. Okay, see here, these are ring compounds and also contains one heteroatom. Okay, they are in sense heterocyclic compounds, but generally these are not because they did not show any aromatic property, and also these are very unstable compounds, and we are not seeing any conjugated double bonds in these structures. Okay, that's why these are not heterocyclic compounds. Okay, heterocyclic compounds are 5 or 6 membered rings. They are stable and they possess some degree of aromatic properties. Okay, here these heterocyclic compounds are abundant of plant and animal products. Okay, for example, alkaloids, dyes, drugs, and proteins, enzymes, etc. All these are representatives of this heterocyclic compound. And let us see the definition of these heterocyclic compounds. Before the definition, okay, we have to know the meaning of this title, that is hetero. Hetero means other than carbon atoms. Other than carbon and hydrogen. Okay, and next, cyclic compounds. Cyclic compounds means ring compounds. Ring compounds. Okay, here these cyclic compounds are again divided into two types. That is homocyclic compounds. Homocyclic compounds and heterocyclic compounds. Heterocyclic compounds. Homocyclic compounds means the compounds contains same atoms. Okay, for example, cycloalkanes. Like here we are taking cyclopropane, that is CH2, CH2, CH2. Okay, this is a cyclopropane. In this structure, it contains 3 carbon atoms. Okay, that means the compound is having same type of atoms. Okay, this type of compounds are called homocyclic compounds. That means same type of atoms. Okay, and heterocyclic compounds means they contain different atoms. For example, okay, this is the structure of furan. Okay, in this, we are observing this structure. We are seeing 2 types of atoms here. One is carbon atoms and another one is heteroatom, that is oxygen. 2 types of atoms, that means different atoms. Okay, those compounds are called heterocyclic compounds. Okay, the heteroatom will be oxygen, nitrogen and sulfur. Okay, the heteroatom will be oxygen, nitrogen and sulfur. Definition of heterocyclic compounds. Okay, heterocyclic compounds are 5 or 6 membered rings, which includes one heteroatom in the ring and exhibit aromatic properties. So this heteroatom may be oxygen, nitrogen or sulfur. Okay, let us see the examples of this one. This is furan, thiophene, pyrrole, pyrene. Okay. These are the examples for heterocyclic compounds. Okay, we are having a ring structure. Okay, there is a carbon chain and one heteroatom. There is a oxygen in furan, sulfur in thiophene, nitrogen NH in pyrrole, nitrogen in pyridine. Okay, out of these four, three are five-membered rings. That is furan, thiophene, pyrrole. These three are five-membered rings, and pyridine is a six-membered ring. In this, all carbon atoms are sp2 hybridized. Okay, carbon atoms are sp2 hybridized, and also the heteroatoms which are present in these rings. That is nitrogen, oxygen, nitrogen, sulfur. These are also sp2 hybridized. That means the structure of these are planar. The ring is planar. We are having planar ring. Okay. The general formula, molecular formula of these are furan, that is contains C4H4O. Okay. And thiophene C4H4S. Pyrrole C4H5N. And pyridine C5H5N. Okay, that means it contains four carbon atoms. 1, 2, 3, 4. Okay, four carbon atoms and one heteroatom. If the heteroatom is oxygen, then it is called furan. If the heteroatom is sulfur, then it is called thiophene. If the heteroatom is nitrogen, then it is called pyrrole. And if the heteroatom is nitrogen again, but it is a six-membered ring, it is called pyridine. Okay, that means these three are having four carbon atoms and one heteroatom, and in pyridine contains five carbon atoms and one heteroatom. Okay, this is the definition of heterocyclic compounds. Classification of heterocyclic compounds. Okay. Depending on the size of the ring, these heterocyclic compounds are divided into three types. Heterocyclic compounds. Divided into three types. Okay, those are five-membered heterocyclics, five-membered heterocyclics, six-membered heterocyclic compounds, and next condensed 6-membered heterocyclic compounds. Okay, see here, these five-membered heterocyclic compounds means the ring contains five atoms, including heteroatom. Totally, the ring contains 5 atoms, in which 4 are carbon atoms and one is a hetero atom. Okay, these 5 membered heterocyclics are again divided into 2 types. Membered heterocyclic compounds divided into 2 types. Okay. Depending on the number of heteroatoms. Depending on the number of heteroatoms, the 5-membered heterocyclics are again divided into 2 types. That is, compounds containing one heteroatom and compounds containing two heteroatoms. Two heteroatoms. That means in these compounds we are seeing only one heteroatom. For example, furan, thiophene, and pyrrole. Okay. In these structures, we are seeing only one heteroatom and remaining are carbon atoms. Totally, the ring contains 5 atoms. Next one, compounds containing 2 heteroatoms. Okay, that means in which the ring contains 2 heteroatoms. Okay, for example, oxazole and thiazole, in which we are seeing 2 heteroatoms, that is oxygen and nitrogen. Okay, and here in thiazole we are seeing sulfur and nitrogen, 2 heteroatoms in the ring. Okay, this is the 5-membered heterocyclic compounds. And next one, 6-membered heterocyclic compounds. Okay, these 6-membered heterocyclic compounds are again divided into 2 types depending on the number of heteroatoms present in the ring. Okay, those are compounds containing one heteroatom compound and compounds containing 2 heteroatoms. Okay, for example, for this one is compounds containing one heteroatom. Okay, this is pyridine, this is thiopyrine. These are the 2 examples. Okay, in which these 2 are 6-membered ring compounds and the ring includes one heteroatom. Okay, the formula of this pyridine is C5H5N. Okay, in which it contains 5 carbon atoms. 1, 2, 3, 4, 5. 5 carbon atoms and one heteroatom, that is nitrogen atom. Okay, and in this thiopyrene also contains 5 carbon atoms. 1, 2, 3, 4, 5 and one heteroatom, that is sulfur. Okay, and next one, compounds containing 2 heteroatoms. That means in this, these are 6-membered heterocyclic compounds and in this ring contains 2 heteroatoms. For example, This is a oxazolene. Oxazolene. Okay, it is a six-membered ring, and in which two are heteroatoms. So that is one is oxygen and another one is a nitrogen atom. Okay, these are six-membered heterocyclics. And condensed five are six-membered heterocyclics. Okay, in which the two or more rings are fused together and to form another compound, another heterocyclic compounds. Those are called condensed five or six-membered heterocyclics. For example, this is called quinoline. Also quinoline. Indole. Benzofuran. Benzofuran. Okay, these are examples for condensed five or six-membered rings. Okay, in this quinoline, isoquinoline, these two are contains six-membered rings, in which quinoline contains two rings. Okay, one is a carbocyclic ring and another one is a heterocyclic ring. Carbocyclic ring means the ring contains only the carbon atoms, and heterocyclic ring means in which one heteroatom is present in this ring. Okay, that means the quinoline is formed by the fusion of in one carbocyclic ring and one heterocyclic ring. Okay, and isoquinoline is also formed by the condensed of carbocyclic ring and one heterocyclic ring. Okay, and in indole, these two are six-membered rings. But in indole, carbocyclic ring is a six-membered ring and heterocyclic ring is a five-membered ring. Benzofuran is also contains one carbocyclic ring and one heterocyclic ring. Okay, this is about a classification of heterocyclic compounds. And aromatic character of heterocyclic compounds. The furan, pyrrole are resonance hybrids and which gives the number of contributing structures. Okay, let us see the general. This is the general resonating structures of heterocyclic compounds. Okay, that is a furan, pyrrole. Okay, in this structure one is called a resonance hybrid structure of these heterocyclic compounds. Okay, and this structure 2 and 3 are slightly more significant than structure 4 and 5. Okay, in this structure 2, 3, 4, 5 are having some negative charge, some charges on these structures. So these are called contributing structures. And next structure 1 is the resonance hybrid structure. Okay, and here the resonance energy of these furan, pyrrole is half of the resonance energy of benzene, because in benzene it contains two resonance hybrid structures. Okay, the resonance energy of benzene is 37.9 kilocalories per mole, and furan contains only 16 kilocalories per mole. Thiophene is having 27 kilocalories per mole, and pyrrole is having 21 kilocalories per mole. Benzene is having higher resonance energy, okay, than furan, thiophene, and pyrrole, because benzene is having two resonance hybrid structures. Okay, but in furan, thiophene, pyrrole, these are having only one resonance hybrid structure. Okay, so the resonance energy of these are furan, thiophene, pyrrole are half of the resonance energy of benzene, that is 37.9 kilocalories per mole. Here X equal to oxygen, nitrogen or sulfur. The carbon atoms which are present in the ring are sp2 hybridized. Okay. This is 1, 2, 3, 4. Okay. 4 carbon atoms are sp2 hybridized, and also the heteroatom is also sp2 hybridized. So the structure of these compounds are planar. That means the ring is planar ring. Okay. In which this ring contains 6 pi electrons. Okay, that means 2 are double bonds from heteroatom. Totally the ring contains 6 pi electrons, and it obeys Hockel's rule. Hockel's rule, that is 4n plus 2 pi electrons. 4n plus 2 pi electrons. Here n equal to 1. Here n equal to 1. The number of rings. Okay. In furan, thiophene, pyrrole, only one ring is present. So n equal to 1. Substitute this value in this equation. That is 4 into 1 plus 2. Totally it contains 6 pi electrons. So it obeys Hockel's rule. So it is aromatic in nature. Okay, and this furan, thiophene, pyrrole are undergo electrophilic substitution reactions more easily than benzene. Okay, these electrophilic substitution reactions are nitration, sulfonation, and then halogenation. And also Reimer-Tiemer reactions. And let us see the resonating structures of furan, thiophene, pyrrole. Okay. The lone pair of electrons which are present in the oxygen atom involved in a delocalization. That means the pair of electrons are migrated to this one. First we have to number in this ring 1, 2, 3, 4, 5. Okay. The lone pair of electrons are migrated in between oxygen 1 and carbon 2. And next, the bond which is present between carbon 2 and 3 is migrated towards 3, carbon number 3. And we get a positive charge on the carbon, on the oxygen atom, and a new bond is formed between oxygen 1 and carbon 2, and a pair of electrons are present on carbon number 3. Okay, and next, in the lone pair of electrons which are present on the carbon 3 is migrated in between carbon 3 and 4. Okay, then and the bond which is present between carbon 4 and 5 is migrated towards carbon number 5. And we get oxygen contains a positive charge, and a new bond is formed between carbon number 3 and 4, and carbon 5 gets a pair of electrons. And next, the pair of electrons which are present on carbon number 5 migrated to carbon number 5 and oxygen 1. Carbon number 5 and oxygen 1, and the bond which is present in between oxygen 1 and carbon number 2 is migrated towards carbon number 2, and we get double bond. A new bond is formed between carbon number 5 and oxygen. This is the new bond. This is already present. Oxygen is positive charge and a pair of electrons. And next, this pair of electrons are migrated in between carbon 2 and carbon 3, and the bond which is present in between carbon 3 and carbon 4 is migrated towards carbon number 4. And here a new double bond is formed between carbon 2 and 3 and a pair of electrons on carbon number 4. These pair of electrons are migrated to this one, and the bond which is present in between carbon 5 and the oxygen is migrated towards oxygen, and we get the structure number 1 again. Okay, this is the structure 1 and structure 2, 3, 4 and 5. We are getting resonance hybrid structure again. Like this, we also write the resonating structures of thiophene and pyrrole. These are the resonating structures of thiophene. And next, resonating structures of pyrrole. Okay, these are the resonating structures of pyrrole. Okay, so this is about the aromatic character of heterocyclic compounds. Okay, these are in the ring contains conjugated double bonds, and these are having totally 6 pi electrons, and it obeys Huckel's rule, and it undergoes electrophilic substitution reactions more easily than benzene. The resonance energy of this pyrrole, thiophene, furan is half of the resonance energy of benzene. In pyrrole, it is 16 kilocalories per mole. In thiophene, it is 27 kilocalories per mole, and in furan, it is 21 kilocalories.